14 billion years ago, there was nothing. Or better put, everything was condensed in a point particle that held everything. Everything that exists, all mass and energy. Space-time, as we understand it now, didn't yet exist. The universe hadn't started expanding yet. Entropy was at a minimum. Then, suddenly, everything changed. Space-time started expanding after a Big Bang. Mass and energy started spreading out across the universe. In these first moments of the universe, it was far more dense and chaotic than it is now. In these briefest first moments, antimatter existed, having been generated in smaller quantities than matter, and shortly thereafter annihilating. Primordial black holes as small as a coin could have existed in this dense, energetic primordial ooze of the young universe. A moment in time so energetic and chaotic that we still see reverberations of it today through background cosmic radiation. They should have called it the Big Boom. Sounds better than the Big Bang. Anyways, this is the start of time as we understand it. Well, space-time. The two are intricately linked. The universe kept expanding, mass and energy kept spreading out. The fabric of time kept growing, expanding the universe as it became a bigger and bigger place. Temperatures across space started dropping. Density in the universe started getting lighter and lighter as there was more space for the universe to spread out to. Dark energy during this time continually accelerated the universe and helped it grow. Over millennia, some of this newly ejected mass and material would condense through gravity into clouds. Over more millennia, some of these clouds would attract and collapse through gravity, sometimes coming together with more and more pressure, causing nuclear reactions if the pressure was great enough, and then igniting the now compressed mass, becoming stars of different types. Some of these dust clouds would coalesce, but with less pressure, not enough to ignite any type of nuclear reaction. These would become planets, rocky or gas planets. In the case of our solar system, part of the dust clouds from which it formed must have originated in a supernova, since heavy metals exist throughout our solar system. The calcium, carbon, and iron in your body were made in a stellar forge that seeded the early solar system. In the center of our solar system, like so many others, so much mass would accumulate at the center and generate such gravitational pressure that fission was possible, and the sun was lit. Like most solar systems, our star is in our center, orbited by the smaller planets. Further out from the center of the solar system, other groupings in gas clouds would form through gravitational attraction. Over even more millennia, these protoplanets would coalesce, and their temperature and geological activity will calm down, making the surface less hostile. A protoplanet's gravitational force might lead it to forming a gas atmosphere. And in cases where the temperature was just right, not too hot, not too cold, liquid water could form. With even more time passing and the right conditions, life might appear. More millennia would pass, and life through random mutations would change and evolve. Life that is best suited for survival due to these random mutations would grow and multiply. This genetic opera, playing out across billions of entities over billions of years, would lead to Earth being covered with a diversity of biological life. Among Earth's countless species, one type of mammal with advanced pattern recognition capabilities and being able to easily handle and manipulate tools would develop the ability to change its environment, and over time would reign supreme over all other forms of life on the planet. This species, Homo sapiens, would spread across the entirety of the Earth's surface. Humans, for better or worse, would become Earth's dominant species, and the only species that we know of that is capable of industrialized scientific society. Humans are okay. Today and here, you are biologically a human on the third planet from the sun of the solar system. It's been 14 billion years since the birth of the universe, since the start of creation and existence. Our little blue and green planet is 4 billion years old. Your species is 500,000 years old. With time, on Earth, permanent settlements were made, agriculture developed. The first steps of what will become culture, art, and the sciences started growing. Civilization developed about 5,000 years ago, depending on who you ask. Many ancient cultures developed alongside rivers, deltas, or the ocean, and spread out from there, eventually spreading across the Bering Strait to the American landmasses, and across the islands of the Pacific and the rest of the world. Over time, hundreds of nations and countries, thousands of peoples, divided up the Earth's landmass among them. You are part of a brilliant, belligerent technological civilization, the only civilization to have ever engineered a way to destroy itself, like a psychopath holding a gun to its own head. The sciences and the arts gave humanity a way to pass accumulated knowledge down between the generations, which would then add more and more to it, allowing us to develop our cultures and sciences. Our species is capable of great love and beauty, and unmistakable horrors and terrors. Alongside our weapons of war, humanity has developed a vast library of all sorts of cultural and artistic works that describe our experiences in this life and in this universe. The planet that you live on has a diverse landscape and types of life: oceans, deserts, plains, fields, mountains, and all inhabited by a wide range of plant and animal life. Earth has an active metal core that generates a magnetic field that protects the atmosphere from high-energy particles coming in from across the solar system. Humanity has permanent settlements on all continents: the wet ones, the dry ones, the cold continents, the hot ones, the ones all the way up and all the way down to the sea level, or below. Global affairs culturally, politically, and economically are dominated by the United States of America, the global hegemon, the magnum opus of imperialism and capitalism. To the east, you have the other major players and hundreds of other individual cultures with their own language, stories, lessons, myths, art, and history. Nearby in space, we have the Moon, Earth's only satellite, orbiting at a distance of an average 239k miles or 384k kilometers away, having a period of about 28 days of rotation around the Earth. The Moon is about 1,080 miles or 1,740 kilometers across, making it about 1/4 the size of Earth. The Moon has a minimal atmosphere and about 1/6 the gravity when compared to Earth. First visited by humanity by NASA's Apollo 11 mission in 1969. Nice. And multiple nations have landed rovers on it, including Russia, China, and India. As the second space race heats up, China and the US are both planning crewed missions to return to the Moon within the next decade, and the United States has announced plans of putting a space station in orbit around the Moon called the Lunar Gateway Station. Looking at our other neighbors in our neighborhood in the solar system, we have Mercury, which is the smallest planet and closest to the Sun. It's a rocky, cratered world with a thin atmosphere. It has extreme temperatures, over 800 degrees Fahrenheit during the day and down to negative 290 degrees Fahrenheit at night. Mercury is actually shrinking. As its iron core cools, it contracts, causing the surface to wrinkle and shrink. Mercury has a massive magnetic core, almost 2/3 of the whole planet's size. Considering its diminutive size, that's a huge proportion. Mercury, like Venus, doesn't have any moons. Venus, the second planet from the Sun, is similar in size and structure to Earth. It's covered in a thick layer of clouds, making its surface impossible to see from space without infrared technology. Venus is known for its extensive volcanic activity and its sulfuric acid clouds. Its surface temperature can skyrocket to close to 900 degrees Fahrenheit, making it the hottest planet in the solar system. Venus rotates in the opposite direction to most other planets, and it spins very slowly. It actually takes longer to complete one rotation on its axis than it does to orbit the Sun. Venus's hostile environment makes it difficult to explore, since it's capable of destroying or rendering inoperable probes that land on its surface. The fourth planet from the Sun and closest to us on Earth is Mars. Earth and Mars are kind of similar, except that Mars is colder, barely has any atmosphere, and it has a dead core unlike Earth. There's no magnetic field protecting Mars's atmosphere from solar winds. Mars is dead on the inside like so many of us. Mars is known as the red planet due to it being covered in iron oxide, or rust. That's what gives it its reddish appearance. It's about half the size of Earth and has a very thin atmosphere, mostly of carbon dioxide. Mars does have the largest volcano and the deepest, longest canyon in the solar system. Although it has a thin atmosphere, it still has weather, including clouds, winds, and dust storms. Some of its largest dust storms can last for months and cover the entire planet. NASA has been successful in landing rovers in Mars, with the first ones being Viking 1 and 2 in 1975, and most recently the much larger Perseverance rover, sent to study the Martian surface and collect samples for a future return mission. Russia and the former Soviet Union also made several attempts to send probes to Mars with mixed success. They were able to successfully land the Mars 3 in 1971. China landed the Tianwen-1 in 2020 on the Red Planet. India's space mission made history with their Mars orbiter mission, Mangalyaan, in 2013. It marked not only India's first mission to Mars, the first Asian nation to reach Mars, and on its first try. Olympus Mons on Mars is the largest volcano system in the solar system. It is about 14 miles tall, which makes it about 3 times the height of Mount Everest, Earth's highest peak, which is roughly 5.5 miles off of sea level. Olympus Mons has a base diameter of 370 miles, which is roughly equivalent to the size of the state of Arizona in the United States. Valles Marineris, otherwise known as Mariner Valley, is the largest canyon system in the solar system, extending over 2,500 miles or 4,000 kilometers. It stretches across 1/5 of the entire circumference of Mars. This makes it 10 times longer than the Grand Canyon in North America and 3 times deeper, with depths of over 4.3 miles or 7 kilometers. It extends roughly from the Martian equator to the equivalent of southern Siberia or Australia on Earth. Mars is orbited by 2 moons, Deimos and Phobos. Deimos is the smaller and outermost moon of Mars. It is named after the Greek god of terror and dread. It has a diameter of approximately 12.4 kilometers, 7.7 miles. It has a very irregular shape, resembling an elongated body with a lumpy surface. Deimos is heavily cratered and its surface is covered in loose boulders and rocks. This moon has a very thin, tenuous atmosphere composed primarily of carbon dioxide. Phobos is the larger and innermost moon of Mars. Phobos is named after the Greek god of fear. It has a diameter of approximately 26.8 kilometers, 16.7 miles. It is tidally locked to Mars, meaning the same side always faces the planet. Due to its close proximity to the planet of Mars, Phobos is gradually falling towards the planet and is predicted to be destroyed in about 30 to 50 million years. Moving further away from Earth, we've arrived at the asteroid belt. The asteroid belt is a region of space between the orbits of Mars and Jupiter. It is roughly 230 to 330 million miles away from Earth. It consists of millions of small rocky objects called asteroids. These asteroids are primarily composed of rock, metal, and ice, among other elements, although often depicted as a densely packed field in the media. The asteroid belt is mostly empty space. The total mass of all the asteroids in the belt is estimated to be less than of Earth's moon. The largest asteroid in the asteroid belt is Ceres, which is considered a dwarf planet. It has a diameter of about 590 miles, or 1,000 kilometers, and accounts for around 1/3 of the total mass of the entire asteroid belt. Contrary to popular belief, the asteroid belt is not hazardous for spacecraft to travel through. Despite the large number of asteroids, their vast distances from each other make encounters with them unlikely. In fact, the average distance between asteroids in the belt is about 600,000 miles, nearly 1,000,000 kilometers, making it quite spacious. The probability of a spacecraft colliding with an asteroid in the asteroid belt is extremely low. Sorry.